A tangent to a circle is a straight line that touches the circle at just one point. So in this picture we have a tangent called T that cuts this circle at a point called P. So P is the only point of intersection between T and the circle. Since P is a point on the circle, we know that the distance of the centre of the circle C to P must equal the radius r of the circle. Now we are going to prove that the line drawn from the centre of a circle to the point of contact of a tangent to a circle is perpendicular to the tangent. So in this case we're going to prove that the line segment CP is perpendicular to the tangent T. What we do is we pick a point x on the tangent T, so x is an element of T, but x is a point that's not point P. So x can be any point on the line T, but not the point P. We can make x as close as we like to P, as long as it's not equal to P. Now, since x is not equal to P, obviously x is not on the circle, because the only point that's on both the line and the circle is the point P. Not only is x not on the circle, but x must be outside the circle, because if x was a point on the line T inside the circle, then the line T would cut the circle at 2 points, and that's not the case. Now if a point is outside the circle, it means the distance of the centre of the circle to that point must be greater than the radius, so the distance of C to x must be greater than r. But r is just the distance of C to P. So that means that the distance of C to x is greater than the distance of C to P for all x, where x is any point on the tangent other than the point P. So x can't be point P. So we can see that the distance of C to x is always greater than C to P, no matter how close x is to P. This symbol here just means for all x. So this means that the distance of C to P must be the shortest distance of the point C to the tangent T. Because if we pick any other point on the tangent, then the distance of C to that other point is greater than the distance of C to P. Well, we know that the shortest distance of a point to a line is the perpendicular distance of the point to the line. So now we've proven that the line CP must be perpendicular to T.